Okay, now that we know how to convert from one side of the chemical reaction to the other, or on the same side of the chemical reaction, now we have to talk about, okay, I'm not going to have an abundant amount of chemicals for every single chemical reaction I have. My boss may just tell me, hey, you only have 10 grams of this, make it work. Okay, so we have to kind of talk about, well, if I'm only given a certain amount of something, how do I decide when the reaction is going to stop occurring, okay? And that's where limiting and excess reagents, or we can kind of think of it as a reactant, okay? Reagents is just a fancy word for reactant, okay? A limiting reactant is exactly what it sounds like. It's limiting. It limits how much of something I can make, right? It means that it's going to be the first reactant that's used up during the course of the chemical reaction, okay? So if one thing limits, that means something else has to be left over, okay? And that's called an excess reactant. And sometimes I'll write excess as XS, okay? So just keep that in mind. And we saw this with our s'more activity, but we can also give an example with our brownies, right? That we were using before. So if we use our same chemical reaction for brownies, if I have 3 brownie mixes, unlimited amounts of water, 4 cups of oil, sorry, that was a typo, and 6 eggs, how much or which ingredient will run out first? Okay, so let's take a look at this, okay? Ultimately, I have to see who is going to stop how many brownies I can make. So I know it's not going to be water because I have an unlimited amount of water, right? I can just turn the faucet on and have all the water I want. Luckily for us, right? Other countries don't have that capability. So be thankful for your running water. Anyways, if I have 3 brownie mixes, that means I can make 3 times the amount of something, because I just need 1 brownie mix for each batch of brownies. Water can't be run out first because we have unlimited amount. Oil, if I have 4 cups of oil and it only takes me a half a cup of oil, I am going to be able to make, let's see, how many times does 0.5 go into 4? It's going to be 8, so I could make 8 batches of brownies. So this is going to be 8 times. I only have 6 eggs. If I need 3 eggs for a batch of brownies, that means I'm only going to be able to do this 2 times. So eggs are actually going to run out first, okay? Everything else is going to be considered in excess, okay? So brownie mix, water, and oil will all be in excess. If something is limiting, it can't be in excess, okay? It's going to be either one or the other. How many brownies can I make then? Well, if I can do this reaction twice, I'm going to make 32 brownies. Okay, so let's look here. I know that it says there's 2 different ways to determine the limiting reactant, but I'm just going to show you one way just to kind of keep it simplified. Okay, when we find limiting, we have to convert to the products, right? Because I have to figure out how much product I'm going to make. So what I'm going to do is I'm going to compare the moles, or determine the amount of product made by using both reactants, okay? So, with that being said, if I'm given moles, I just have to figure out which moles, or how many moles of the product are formed. So, for example, you can say question mark moles of NH3, and I'm given 2 moles of N2, right? And I'm going to convert mole of N2 in the bottom, mole of NH3 in the top, and for every 1 mole of N2, I will have 2 moles of NH3, which means I can make 4 moles of NH3 with this. And then I'm going to do the same thing with H2. I'm going to say question mark moles of H2 is equal to 3 moles of H2. Okay, I'm going to put moles of H2 in the bottom, moles of NH3 in the top, and for every 3 moles of hydrogen, I have 2 moles of, so 3 times 2 is 3, or 6. 6 divided by 3 is 2, so that means I can make 2 moles of NH3, okay? Now, I converted both of these to NH3, so now I can compare them. And what we notice is I can only make 2 moles, right? Kind of what we did up with our brownies. I can't make 4 moles. Technically, N2 can make 4, but H2 says no. I can only make 2, okay? I can only make 2 moles, so I'm going to stop the chemical reaction, okay? So in this case, H2 is the limiting reactant, and N2 will be in excess. Okay, now here's the trick. You have to do this, and you have to convert into moles. Don't convert it all the way to grams, okay, because molar masses will affect how much of something I can make. Okay, let's look at another example. So number 2 says, I have 1.75 moles of phosphoric acid, so I'm going to tell you phosphoric acid is H3PO4, reacts with sodium hydroxide, NaOH. Okay, so we're doing a double replacement reaction. So I'm going to go inside, outside. So hydrogen and OH is going to make water, and then I'm going to make sodium phosphate. So I'm going to have H2O and Na3PO4. Okay? And then I need to balance my chemical reaction. So oxygen shows up in 3 places. I'm going to skip hydrogen. I'm going to start with phosphorus, so 1 and 1. 1 sodium, 3 sodium, so I'm going to put a 3 here. 3 plus 3 is 6. I only have 2 here, so I need to put a 3 here. So then oxygen will be 4 plus 7, or 4 plus 3 is 7. 3 plus 4 is 7, so it's balanced. Okay, so we have to figure out whether phosphoric acid or sodium hydroxide limits the reaction. Okay, now how is this problem different than our first one? Hopefully you're thinking, well, I have 2 products. Which one do I convert to? I don't care which one you convert to, as long as you convert both of the reactants to the same product. So I'm going to convert both of my reactants to water. Okay, so I'm going to say question mark moles of H2O is equal to my 1.75 moles of H3PO4. Okay, and for every 1 mole of H3PO4, I have 3 moles of H2O. Okay, so 1.75 times 3 is 5.25 moles of H2O. Okay, and I'm going to do the same thing, and I'm going to make sure that I convert to the same mole, because I need to have something to compare to this one. So I don't want to change the variable. So I'm going to say question mark mole of H2O is equal to 5 moles of NaOH, sorry, mole NaOH. I'm going to say for every 3 moles of NaOH, I will have 3 moles of H2O, which ultimately this is 1, so that means I can only make 5 moles of H2O, which means this is the smaller amount, so that means that NaOH limits how much water I can make. So NaOH is considered the limiting reactant. So number 3 says how many grams of each product can be made. After I figure out who limits the reaction, I use that quantity to figure out everything else. Okay? So for that being said, I'm going to have to use 5 moles to figure out how many grams of water and sodium phosphate are created. So let's look at this. So I'm going to say question mark grams of H2O is equal to 5 moles of sodium hydroxide, and for every 1 mole of sodium hydroxide, not 1, 3 moles of sodium hydroxide, I had 3 moles of H2O. And for every 1 mole of H2O, I have 18.02 grams of H2O. So then I have to plug this into my calculator, which is basically 5 times 18.02. So I will create 90.1 grams of H2O. Okay, and then ultimately I can do the same thing for sodium phosphate, but I need to make sure that I use the same conversion here. So I have to say question mark grams of sodium phosphate is equal to 5 moles of sodium hydroxide, because sodium hydroxide restricts how much product I can make. Okay, this isn't all that deals with limiting reactant. We also are going to be able to figure out how to solve for excess, meaning if I have something in excess, how do we figure out how much of it is left over? But we'll do more of those calculations in class. Thanks for watching. See you guys.